Okay, so we're covering section 3.3 today, which is dividing polynomials.
I just saw Lizzie coming from cafeteria going.
Yeah.
Well, that's why
that would be where the body was then.
Yeah, so she came from the.
Okay, so dividing polynomials is something that we need to be able to solve and find x-intercepts, because remember the problems that we were doing before, when you were finding your x-intercepts, they all factored, and I said they usually don't factor, but these do, just because we haven't learned another way to solve it. To be able to solve it the other way, you have to be able to divide. So that's what we're going to learn today, is how to divide, and then we are going to apply that to polynomial functions on Wednesday. Okay, so again, I kind of just told you this, but the reason why we have this is sometimes a polynomial does not factor. Or not necessarily that it doesn't factor. We don't have a way of factoring it. Okay, so how about have a method for factoring? So it does not have a method for factoring. It technically does factor, we just can't figure it out based on our AC method or our grouping or whatever it is. Okay, so here's like a much simpler example. The number 15, can we factor the number 15? Give me two numbers that multiply to give me 15. 5 and 3, right? 3 times 5. That is easily factorable, right? That's something we can just look, easily factorable, because we can just look at it, okay? What about the number 840? That is 3 times what? Do you know? Okay, so like, I don't know off the top of my head, right? How would you figure out what it is? Use calculator and do what with it? Do 840 divided by 3 and it tells you that other number, okay? So this is one that's not easily factorable, right? So instead, we divide to figure out the other factor. Does that make sense? So essentially that's what we're doing with polynomial functions is I have this big, long, huge thing. I don't know how to factor it. So what I'm going to do is I'm going to divide by something that I know is a factor, and it's going to give you the other part here. Kind of like the idea of 3 times whatever it is. What is 840 divided by 3? 280. Okay, so it gives me that other piece by dividing. 840 divided by 3 gives me the other piece that it multiplies into. Okay, so we have 2 methods for factoring. One that is long, but it works every time. And another that is a shortcut, but it works not every time, just most of the time. Okay, so 2 methods. The first one we are going to learn is long division. Guess what? That's the long one.
Joey was that side as well. I saw it.
Technically, you already know how to do this. We are just going to apply it to x's. Let's remember how to do long division by hand without a calculator. Okay, so for example, let's just do regular numbers. Let's do 3,983 divided by 26.
I think it was Joey.
Okay, so to do this by hand, I write it out. I'm going to put 26. I'm going to put my little division bar thing, and then I'm going to put 3,983 inside my division bar.
Did it happen?
Oh, did you 100% see Lauren do it?
I 100% saw it, yeah.
What's your first step for long division?
I'm asking Joel.
I feel like yes, I feel like
Does 26 go into 3? No, it doesn't. So technically I could put a 0 up there, or you don't have to, it's up to you. I'm going to move over to the next place value. Does 26 go into 39? Yes. How many times does it go in? 1 time. I'm going to put a 1 above the 9. And then I'm going to do 1 times 26 and write it underneath 39. 1 times 26 is 26. What do I do with that 26? Subtract it. So I'm going to take away 39 minus 26 and I get 13. You double check to make sure you did your division right. Does 26 go into 13? No. Bring down your 8. Does 26 go into 138?
Yes.
Yeah, a few times. 5 times. Good job. Did you do it on your calculator?
Yeah, I just did it in my head.
Good for you. Okay, so it goes in 5 times. 5 times 26 is 130, right? What do I do with that number? I subtract it off. What's 138 minus 130? 8. I can't put 26 into 8, so I bring down the 3. Can 26 go into 83? Yes. 3 times?
Yes.
And I get 78. 3 times 26 is 78. Subtract it off. I have a remainder of 5 here. So you could put your remainder a couple ways. You could say like R5 is how you first start learning how to do it. How do you do it as a fraction? 5 over 26. So this is 153 and 5/26. Okay, that's how you do long division with numbers. I am now going to do a problem right next to it so we can refer back to see the exact same steps. Okay, so this problem is going to have letters in it. It's a polynomial. It's a short one, okay? So if I had the problem, x squared plus 10x plus 21, and I want to divide that by x plus 3. Okay, I'm going to set it up the exact same way as the other one. So the 26 is what goes outside the division bar. So the x plus 3, it's what's going to go outside the division bar. I'm going to put my little division bar. I'm going to put x squared plus 10x plus 21 inside of it. Okay, before I said how many times does 26 go into 39? Okay, here I'm just looking at the first numbers. I don't care about this 3 whenever I'm like seeing how many times it goes into it. So it's the same idea. How many times does x go into x squared, or x times what equals x squared? X times x equals x squared. So that's what you're going to put at the top. What do you need to multiply this by to get the first term? Okay, so x times x is x squared. You actually put the x above the 10x. The idea is there's 2 terms here, there's 2 terms here, kind of like 26 wouldn't go into 3, so I had to move over 1, same idea. Okay, so x is what's going to be on top because it's x times what equals x squared? X times x equals x squared. Okay, so once I got this 1 on top, what did I do with the 1? Multiplied it by 26 and wrote it underneath. Same thing here. X times x plus 3, write it underneath. What's x times x? X squared. What's x times 3? 3x. Before, once we got that 26, then we subtracted it. Here, instead of thinking about it as subtracting, think about it as changing your signs. Because the problem is if you just put a subtraction sign here, you're going to forget to subtract this piece right there, and it's going to mess your whole problem up. So think of it as changing both of your signs, negative and negative, or if it was already negative, it becomes positive. Okay, and now since we changed the signs, we're going to add them. It's the same idea as subtracting. What's x squared minus x squared? 0. If you don't get a 0 here, you did something wrong, okay? It means that like I could still put 26 into it, essentially is the idea, okay? What is 10x plus negative 3x? 7x. Okay, so this is where we got like 13 here. What did we do next here after we got the 13? We brought down the 8. It's the same thing. I need to bring down the next term here, bring down the 21. Okay, so now how many times does x go into 7x, or x times what equals 7x? 7. And is it a positive 7 or a negative 7? Positive 7. See, put the positive 7 on top. Same idea as before. Once I got like the 5 on top over here, I'd do 5 times 26 and wrote it underneath. So I'm going to do 7 times x plus 3 and write it underneath. What's 7 times x? 7x. What's 7 times 3? 21. I need to subtract it. So you need to change both of your signs. 7x minus 7x is 0. 21 minus 21 is 0. So there's no remainder here. So my answer is x plus 7. What we are going to use that information to tell us is, I know that x squared plus 10x plus 21 factors into x plus 3 times x plus 7. Okay, again, your answer for this is just the x plus 7 for a division problem, but trying to relate it to what we're going to use it for. Did I already know how to factor that problem? Yeah, I could use AC method. Two things multiply to give you 21, the add to give you 10, it's 3 and 7. Okay, but if this was a problem that I couldn't factor, this tells you what it factors into. Does that make sense? Okay. Okay, so we're going to spend some time on that. Okay, we're going to do those. Sometimes they get a little yucky. So we're going to do a few of them until we kind of get the hang of it, and then we'll move on to synthetic division. Okay, so let's do some more of those. So let's do x squared plus 14x plus 45 divided by x plus 9. So this one's pretty easy also, just getting the hang of it. Okay, so you're going to put x plus 9 on the outside. You're going to put your division bar and x squared plus 14x plus 45. Okay, so first step, how many times does x go into x squared, or x times what equals x squared? X. Okay, I'm going to put that above the 14x. So now I need to multiply x times x plus 9. X times x is x squared. X times 9 is 9x. We need to subtract it, so change all of your signs. So x squared minus x squared is 0. 14x minus 9x is 5x. Bring down your next term. So I'm going to bring down the plus 45. How many times does x go into 5x, or x times what equals 5x? 5, and it's a positive 5. Multiply it. 5 times x is 5x. 5 times 9 is 45. Change your signs. And 5x minus 5x is 0. 45 minus 45 is 0, so there's no remainder. So my answer here is x plus 5. Yes, sir.
So we only related to the first term, like
when you're figuring out what your number on top is, yes, you only use the first term. Because the last two were pretty, or both of these were pretty simple, and you could kind of see that like they go into both 9 times, but it's not always the case like that. So you just look at the first term. Okay, so again, what did this tell us that x squared plus 14x plus 45 factors into? X plus 9 times x plus 5. Okay. Let's do one that's longer and a little bit more difficult. Also, both of these I gave to you in descending order. It has to be in descending order or it's going to mess it all up. Okay, it's kind of like the idea of like 3,983. 3,000 is the biggest part of that number, then 900. Like it's already in order. Okay, it has to be in order to be able to divide it. So for this problem, this one's not in order. 4 minus 5x minus x squared plus 6x cubed. And this time we're going to divide it by 3x minus 2. Okay, first thing we need to do is put it in descending order. What's your first or your highest term? 6x to the third power. What's the next one going to be? Minus x squared. And then minus 5x. And then plus 4. I'm going to put that in my division bar. And on the outside is going to be 3x minus 2. Okay, so 3x, how many times does that go into 6x cubed? Or 3x times what gives me 6x cubed? 3 times 2 is 6. X times x squared is x cubed. So it's 2x squared that you're writing above your second term. Okay, I need to multiply. What is 2x squared times 3x? 6x cubed. What's 2x squared times negative 2? Minus 4x squared. Subtract these by changing your signs. Make it negative 6x cubed plus 4x squared. Okay, what is 6x cubed minus 6x cubed? 0, they cancel out. Negative x squared plus 4x squared. It's 3x squared. Bring down your minus 5x. How many times does 3x go into 3x squared? Or 3x times what gives you 3x squared? X. It's a positive x, so I'm going to put plus x on top. You need to multiply x times your divisor. X times 3x is 3x squared. X times negative 2 is negative 2x. We want to subtract those, so you need to change your signs. So minus 3x squared plus 2x. 3x squared minus 3x squared cancels out at 0. Negative 5x plus 2x. Negative 3x. Bring down your next term. Plus 4. How many times does 3x go into negative 3x? Or 3x times what equals negative 3x? Negative 1. So I'm going to put minus 1 at the top. Multiply. Negative 1 times 3x is negative 3x. Negative 1 times negative 2, positive 2. Change your signs. Positive 3x and negative 2. Negative 3x and positive 3x, those cancel out and do each other, or 0. 4 plus negative 2, 2. I have nothing else to bring down, so this is my remainder. How do you write your remainder? 2 over 3x plus 2, and I have to put a plus sign in between it. So it's plus 2 over 3x minus 2. And that's your answer. When it has a remainder, it means that that problem is not a factor of it. And that's something that, like, you know, with numbers. If I took the number, whoa, I just threw that. If I took the number, I don't know, 2,548, and I divided it by 9. Is it divisible by 9?
No,
Why not?
because
Because
it's a remainder.
it has a remainder. Okay, so that's something that you already know because you do that all the time with numbers. So this big long polynomial, 6x cubed minus x squared minus 5x plus 4, does not factor into 3x minus 2 times something because it has a remainder. Okay, and that is actually called there's a theorem for that. I can't remember the name of the theorem, but that's a really big idea, and that's something we need to know when we're trying to factor something. If your polynomial can be divided evenly with no remainder, then it is a factor. It's a factor. Questions about that? Yes, I'm recording. Let me double check. Yes, I am. That'd be real sad. Okay, so we're gonna do, let's do 2 more of those. Okay, and then synthetic division is so much faster and so much easier and very quick to catch on to. So we don't need to spend the majority of our time on that. We need to spend the majority of our time on the long division. Let's do another one. This time with the long division, I'm going to make it where the descending order, there's not one of each, like x cubed, x squared, x, like I'm going to skip one, okay? And I'll show you what we have to do with that. So if I had 6x to the 4th plus 5x cubed plus 3x minus 5 divided by 3x squared minus 2x. This is an example of one that you cannot use synthetic division on, okay? So it's kind of like the idea of solving a quadratic with quadratic formula versus factoring. Factoring is so much easier, faster, quicker for the most part. So usually we choose factoring, but it doesn't always work. Sometimes you have to use quadratic formula. So that's kind of what long division is like your quadratic formula. You can do every problem with it, but it's not really fun to do it with it, okay? So in this case, I have x to the 4th, I have x to the 3rd. Do I have an x squared? No, if you are missing one of your terms, this has to be in descending order with every single exponent. If you're missing one, you have to put a placeholder in. So you have to like add in plus 0x squared. And this should kind of make sense because with normal long division, if I didn't have any tens, what would be there in the tens place? A 0. Like numbers already have placeholders in them, okay? So that's the reason why we have to put a placeholder in, is so that we can still divide the normal way, okay? So let me move down a little bit. 3x squared minus 2x on the outside, dividing into 6x to the 4th plus 5x to the 3rd plus 0x squared plus 3x minus 5. And you have to put in placeholders for synthetic division also. So just make sure you're always putting in all your placeholders if you don't have every single degree of x. Okay, let's divide it. 3x squared. How many times does it go into 6x to the 4th? Or 3x squared times what? Do y'all want to try this on your own first?
No, not yet.
Not yet. Okay, let's do it together. How about you figure out that number on top and write it underneath first? We'll ease you into it. So 3x squared times what equals 6x to the 4th? Write it on top and multiply it underneath. And then I'll show you the answer so you can check and move on. Okay, so you should have got 2x squared on top, because 3 times 2 is 6. X squared times x squared is x to the 4th. Multiply it. When you multiply, you get 6x to the 4th minus 4x to the 3rd. And then you need to change your signs. So it's going to be negative 6x to the fourth plus 4x to the third. 6x to the fourth minus 6x to the fourth is 0. It undoes each other. 5x cubed plus 4x cubed. 9x cubed. Bring down your 0x squared. How many times does 3x squared go into 9x cubed? You do that now. Get that number on top and multiply it underneath. Or 3x squared times what equals 9x cubed? Should have got 3x on top. 3x times 3x squared is 9x cubed. 3x times negative 2x is minus 6x squared. Change your signs. Minus plus 9x cubed minus 9x cubed is 0. 0x squared plus 6x squared is 6x squared. Bring down the 3x. How many times does 3x squared go into 6x squared? Write it on top, multiply it out. Or 3x squared times what equals 6x squared? You should have got 2. 2 times 3x squared is 6x squared. 2 times negative 2x is negative 4x. Change your signs. 6x squared minus 6x squared is 0. 3x plus 4x is 7x. Bring down the minus 5. Can 3x squared go into 7x? No. Once you get to the point where this exponent is higher than this exponent, you're at your remainder. Okay, so this goes on top of your fraction. So it's plus 7x minus 5 over your divisor, 3x squared minus 2x. Questions about that? Okay. They're all basically the same with a few little, like the idea is the same for every single one. Make sure you have placeholders in it. Make sure it's in descending order. Once you get down to where this exponent of your divisor is higher than wherever you're at here, that's when you're at your remainder and you just write it on top. There could be 3 things here. There could be 4 things here. Usually it's just 1 or 2 things that go on top of the remainder. Okay, I said we're going to do 2 more. We're actually going to move on and we will have time to practice this. I'll do like one of these at the beginning of every class for a couple days and we'll get the hang of it. Okay, we're going to move on to synthetic division. Synthetic division is essentially the same idea. I just take all the x's out. I only deal with the numbers. The coefficients is all you're dealing with. Okay, so let's talk about synthetic division. Okay, the only time you're allowed to use synthetic division is when your divisor, the thing you're dividing by, is in the form x, I'm gonna say x minus c. That could be a plus sign there. Basically, it has to be like x plus 3, x minus 5, x plus 1/2, okay? It can't be 2x plus 5. It can't be 3x squared plus 2x. You can't divide like that. It has to be your normal plain old like x plus or minus a number, okay? So like the first problem we did, we could use synthetic division for because it was x plus 3. The second problem we could do, because it was x plus 9, we could use synthetic division for this one. The third problem, you can't use synthetic division here because it's 3x minus 2. Does that make sense? And then the fourth problem we for sure couldn't do because we were dividing by 3x squared minus 2x. Okay, so out of those 5 problems, 3 could use synthetic division, 2 have to use long division. Okay, the good news is for our purpose, we usually are factoring by stuff like this. So we're usually going to use synthetic division like 95% of the time. Okay, every once in a while, something's going to happen where we're going to need to use long division, but the majority of the time we're using synthetic division. Okay, so it looks kind of weird at first if you haven't seen it or if you aren't familiar with it. It feels kind of weird, but once you get the hang of it, it's much better than long division. Okay, so our first problem we're going to do is x to the third plus 4x squared minus 5x plus 5, and we are going to divide that by x minus 3. Okay, what we do is we tell what c is. One way to do that is set that equal to 0 and solve. If I set x minus 3 equal to 0 and solve, what number do I get? 3. So 3 is going to go in a box right here. This number is always going to be the opposite sign of this, okay? It's the idea of if x minus 3 is the factor, what's the solution here? 3, because you set it equal to 0 and solve, right? So you actually put the solution here, your x value there. In this part, we are putting our coefficients of each number, or I'm sorry, of each term. What's the coefficient of x cubed? 1. Coefficient's the number in front, right? What's the coefficient of x squared? 4. This is like columns at this point. What's the coefficient of negative 5x? Negative 5. And the coefficient of, oh, sorry, it's just constant. It's just positive 5. Huh? You did it in high school. So now you need one number under each of these, and then we're going to put like an equal sign. Under your constant is always another little box. That's your remainder. And it's always under the constant. Okay, so I was looking to see, whatever. So like on top, this is the coefficient for x cubed. This was x squared. This was for x. And then this is our constant. And your little box goes into your constant every time. Okay, so the way that we get all of our numbers, you start off just by bringing down the first number. So you bring down the 1. Okay, so the way I get the number in the second column is I multiply my x value, my 3 times 1. What is 3 times 1? 3, and I write it up here. So this was, I multiplied here, and I write it up there. Now I add these two numbers together. What is 4 plus 3? 7. To get it up to the next one, I'm going to multiply by 3 again. What's 7 times 3? 21. I add this again. To get the number below the line, you're adding the column. To get it up on top of the line, you multiply by your x. Okay, what's negative 5 plus 21? 16. And now 3 times 16 is 48. And 48 plus 5 is 53. Okay, so your answer is here. You just got to put your x's back in, okay? When we divided by x, it takes away an exponent. So if I started off with x cubed, what's x cubed divided by x? X squared, okay? So this number down here is going to be the x squared now. It subtracts off one of your exponents, right? X squared divided by x is just x. X divided by x is just a number, and that's your remainder. So my answer here is 1x squared, or just x squared, plus 7x, plus 16, and this is my remainder of 53. I write it as plus 53 divided by, what's my divisor? Not just 3, x minus 3, okay? So x minus 3, and that's your answer. Does this polynomial, is it factorable by x minus 3? No, it does not factor into x minus 3 times something because I don't have I have a remainder here. I'm not allowed to have a remainder for it to factor. Okay, let's do a couple more of those. There we go. Okay, let's do number 2 is the problem 5x cubed plus 6x plus 8, and I want to divide it by x plus 2. Okay, you have an x cubed term. Do you have an x squared term? You have to put a 0 in for x squared or it will not line up and it will not work. What am I dividing by here? What number? -2. This is like the root or the 0 or the solution in there, okay? So I'm going to divide it by -2. It's going to be 5x cubed in the first column. My x, you don't have to put this x cubed, x squared above it, but if it's helpful, for sure do it. So my x squared term, I have 0 of them. You have to put a 0. My x term, I have 6 of them, and then my constant is an 8. Put your box under your constant because that tells you that's your remainder. Okay, you're going to bring down the 5. To get it up on top of the line, you have to multiply by -2. What's -2 times 5? -10. -10 plus 0 is -10. -2 times -10. +20. 6 plus 20 is 26. -2 times 26. 52, right? -52. -52 plus 8 is -44. Does this divide evenly? Is it a factor? No, but I can divide it. The answer is this 5. What's the exponent on that now for the x? X squared, because it started off as x cubed, so now it's down to x squared. So it's 5x squared minus 10x plus 26. And you could write this as -44 over x plus 2 or plus -44 over x plus 2. Up to you. Oh, sorry. You could write this as this, in this case, you could write this as -44 over x plus 2. The reason why I put plus every time, because if this was 2 terms, if this was like 2x plus 5, I couldn't put a minus in front of it and be the same thing.
You know, I wasn't looking for this.
Synthetic division kind of makes sense. These were like actually pretty harder problems. They're usually a lot faster and easier than just that. So let's do some more. Let's do some of the easier ones, and then I'm going to show you kind of how we use it. Okay, so let's do this one, x to the third minus 7x minus 6, and divide that by x plus 2. Don't forget your placeholder for x squared. So the numbers on top are -2 that you're dividing by, and 1, 0, -7, -6. Go ahead and work it out. What's your remainder on this one? 0. What does that tell us? It divides evenly, right? It's a factor. So so the answer here, the answer for the synthetic division problem is x squared minus 2x minus 3. The way we use this, though, is now I know that, look at your original problem, x cubed minus 7x minus 6. Do we have any way of factoring that? It looks like an AC method, but x cubed at the front, it's not an AC method problem. We have no possible way to factor that problem. But by using synthetic division, I just learned that this thing factors into x plus 2 times x squared minus 2x minus 3, right? The idea of 15 divided by 3 equals 5. So 3 times 5 equals 15, right? So now look at what's this piece that we found, the x squared minus 2x minus 3. Can I factor that? That's AC method. And I can get all my solutions here now. How many answers does this problem have? 3. One of them is right there. 2 of them are right there. If that didn't factor, which it does factor, but if it didn't, what could I use from there to solve that one? You got this. If something doesn't factor, you can use quadratic formula. Okay, so I'm gonna let me go ahead and factor this. What does this factor into? It's AC method. What do things multiply to get -3 and add to get -2? Yeah, -3 and +1, right? So x minus 3, x plus 1. Okay, so that idea right there is the whole reason why we're learning division, because if I want to graph this polynomial, I have to know in behavior, which I use degree and leading coefficient to get it. The next thing I have to know is x-intercepts. All the problems we did before factored. This problem does not factor. So I have to divide to get it down to something that does factor. And now, what are my x-intercepts for this problem? -2, 3, -1, right? I could then plot those on my graph, use multiplicity. They all have multiplicity of 1 to draw my graph, whatever it looks like, okay? And that's called factor theorem, okay? We got time. So some of the problems you'll be given will look like this. It'll say, solve the equation. This will be on your exam. I'm just going to tell you right now. 2x cubed minus 3x squared minus 11x plus 6 equals 0. Given that 3 is a 0 of the equation. Sorry. Okay, so I said solve it. How many answers does this problem have? 3 answers. What is one of those answers? 3. I told you one of the answers, okay? You got to find the other 2. The way to find the other 2 answers is use division to factor. This does not factor. I cannot use factor like grouping to factor this. It's not going to work, okay? So since it doesn't factor, the way I get my other 2 answers is divide by that. Because when I divide by that, I'm going to get my this piece right here. What is this what is the solution of 3 as a factor? X minus 3, right? So it would factor into x minus 3 times whatever my answer is right here. And then I can factor that piece. Does that make sense? Because then I would get my answer as x equals +3, and then I get 2 more answers in here after I factor it. Sorry, you can't see that very well. Okay, so let's divide it. Let's use synthetic division. What's the number I'm putting at the top here? Is it 3 or -3? 3. You're always putting the 0 at the top, okay, or the solution, or the root. Okay, my coefficients are 2, -3, -11, and 6. The remainder is going to go under the 6. What should my remainder be here? Before I even start, it's got to be 0. How do I know that it's 0? because they told me it is. Like they told me this is an answer, okay? Either I wrote the problem down wrong or I did something wrong if it's not, okay? So bring down the 2. 2 times 3 is 6. When you add it, I'm gonna quit talking because you're probably at a different part than me. Did you get a remainder of 0? Yes, I got 2, 3, -2. So it's gonna be 2x squared plus 3x minus 2. So that's 2x squared plus 3x minus 2. Now I can factor that. How do you factor that problem? Using AC method. We are running out of time, so can I tell you what that factors into? It factors into 2x minus 1 times x plus 2. Next time we will go over a problem and we'll work it all out. So my 3 factors are x minus 3, 2x minus 1, x plus 2. So what are my 3 solutions? 3, what's this one going to be? Add 1, divide by 2. So 1/2. And the last one's going to be subtract 2 from both sides, -2. So 3, 1/2, -2. Okay, I got to show you one more thing real fast. It'll literally take me 1 minute to show you this. The other thing that we use this synthetic division for is the remainder theorem. Okay, so the remainder theorem tells us that if a polynomial, so if f of x is divided by c, then the remainder is f of c. Okay, so let me tell you what that means. That means if I have this function, f of x equals x to the third minus 4x squared plus 5x plus 3, and we wanted to find f of 2, what's one way to find f of 2? Plug it into all your x's. Okay, it might take a little bit because you have to cube it and then you have to square it and multiply it and add that and then multiply it by 5 and add that. This theorem tells me that I can just divide by 2 using synthetic division, and the answer, the remainder is the answer. Okay, so if I bring down the 1, 2 times 1 is 2, -4 plus 2 is -2, I get -4, 5 and -4 is 1, 2 times 2 is, 2 times 1 is 2, 2 plus 3 is 5. So that tells me that f of 2 equals 5. Okay, so this might be a little more writing, but it's less thinking. And especially if it was a longer one, it's a lot less thinking than plugging it in. Okay. Okay, so we will do more of that next time, and we will use all of this next time. Go home and practice synthetic and long division because we're going to be using it a lot on Wednesday.